Hello everyone. In this video, we are going to explore a new feature of LuBan. It is called Glider. Before we look into the function, let's look at a short video.
3D print takes barely any filament, but it can actually fly. It's a super light glider that is weighted at the front that almost works exactly like a paper airplane when you throw it, but this is more durable. This 3D print may...
That's right. We are going to make a similar version of the glider that you saw in the video. Let's open LuBan software. Go to File, Create, Glider. The menu Glider is only available when you download the latest, when you update your LuBan to the latest version. This is the overview of the glider, a preview of the glider. And we have many control parameters. The first set of control parameters sets the fuselage, length, width, and height. Then the cockpit. Then we have wing angle, position, length, width, and thickness. And lastly, we have stabilizer, length, width. Stabilizer refers to the vertical and the horizontal stabilizer. We also have a logo thickness. You can attach wing logo and tail logo on the glider. And the logo is a black and white image. So wing logo looks like this. That's the wing logo that I chose in this example. And the tail logo I'm going to use to demonstrate looks like this. Both of the logo images are black and white. Select wing logo. It will be automatically attached to the wing. And then select the tail logo. It will be attached to the vertical stabilizer. The logo and the main body of the glider are two separate objects, so you can use select to highlight each object separately. The glider refers to the main body, and the logo refers to this. When you save the project, you will get two STL. And if you are familiar with multicolor printing, you can load the two STL to your slicer software and set different colors to the two STL. Your multicolor printer will print the glider main body and the logo with different colored filament. And that way you can make a beautiful glider. Let's briefly look at the control parameters one by one. Fuselage length refers to the main beam. Currently it is 150. We can set it to 200, make it longer, or make it shorter. I'll roll back to 150. Fuselage width refers to the width of the main body. 2, change to 5, change to 10, so you get the idea. Height refers to the direction, the vertical direction. Currently it is 3. You can change to 20. And this is going to be definitely too heavy for the glider. And I'll set it back to 10 to 3. Maybe I'll leave it to 5 for the demonstration of other parameters. Cockpit height is the radius of the hemisphere. 10, set it to 20. Wait, I didn't. 20, it will be bigger. The cockpit is used to balance the weight of the glider. So sometimes the head is too light and you can use a bigger cockpit to put more weight on the front. I'll set it to 10. Wing angle. The wing angle can change from 90 degrees to 30 degrees. If it is 90 degrees, the glider looks like this. It's similar to the one that you saw in the video. And you can reduce the angle to 30 degrees. If you have a fighter airplane, the wing usually looks like this. But if you have a passenger plane, the wing usually looks like that. It depends on the engine of the airplane. If the engine is very powerful, then you will have a narrowed wing, so it fires out, so it flies out like a rocket. But if the engine is mildly powerful, not that powerful, then you would want to have a wing angle, a large wing angle. So the span of the wing gives you more lift. And if you really have a glider that has zero power or a very little power, you often see that the glider in movies, they have vertical, perpendicular to the fuselage. You'll have a wingspan that looks like this. This gives you maximum lift by the wing. So you can try different kinds of design, whichever to see which one works for you. Then we come to the parameters that controls the wing. Wing angle, wing position. The position can be changed from 0, which is the lowest position, to 1, the frontmost position. And a digital number in between gives us a position in between. Wing length refers to the horizontal span of one wing. I can change it to 120, so it's bigger. I can set it to a smaller wingspan as well. Wing width is this section, the length of this section. Wing width 30, I'll reduce it to 20 or increase it to 40. Of course, the larger the wing width, the stronger the lift. And then for the wing parameters, the last one is thickness. Thickness is 0.8. At the tip of the wing, the thickness is half of this value. So at the tip, it is 0.4. It gradually increases to 0.8 thickness at the end of the wing. And this parameter, wing thickness, applies to the two big wings, the horizontal stabilizer as well as the vertical stabilizer. And the algorithm generates them in exact same way. At the end, you will have a thickness of half the value set in wing thickness at the tip. At the bottom, that's connected to fuselage, the width is exactly that value, wing thickness. Anything in between is linearly changed. Stabilizer length refers to the length here. You can reduce the length or increase the length as you wish. In my current implementation, the length is shared by vertical and horizontal stabilizer. Stabilizer width refers to the section that contact with the fuselage. You can increase it or reduce it. And lastly, logo thickness. The logo also has a thickness. You can increase it or reduce it up to your depending on your needs. But of course, if you increase it, this will produce a heavier wing. So sometimes it may not be ideal for the glider. And also, if the thickness is big, the logo on the vertical tail, vertical stabilizer, will protrude out, and it may require support to print it. So ideally, it should be a small value. The glider is completely flat. That means you can print it flat on bed without using any support. That is all for this feature. I hope you enjoy designing a cool glider. Thank you for your attention.